Hello, you're watching Building a Web Application using ASP.NET Core 1.0, Node.js, Aurelia, TypeScript and Webpack in Visual Studio Code, Section 1 of Part 6. I am Raja Mani. I live in San Jose, California. I am very passionate about technologies. I blog at opensource.netter.blogspot.com. This video tutorial is complementing the tutorial blog post series that I post in my blog. In this section of the part 6, we're going to talk about Node.js, and we'll talk about how to download it, install it, and also use the Node Package Manager, which is a very popular package manager for Node.js. And at this moment, this seems to be the most popular package manager out there. And you must have heard about other package managers if you're from Java background or from .NET. You must have heard about Maven, NuGet, similarly Ruby, Gems, and so on. But at this point in time, module count in Node Package Manager is way above all other all of the package managers that are out there, which shows that Node is gaining popularity. TypeScript 2.x is a typed superset of JavaScript that compiles to plain old JavaScript. It runs on any browser, any host, any OS, and it's open source from Microsoft. Visual Studio Code version 1.5.3 is an amazing free IDE that's available on Windows, Mac OS X, as well as Linux. It is not a full-blown IDE, but it is very good and lightweight IDE. You can use Visual Studio Code to develop client-side applications as well as server-side applications using ASP.NET Core or Node.js and whatnot. There are also plugins available for other languages like Python, PHP, and so on. Commander is a substitute for command.exe. If you're a Windows user, you know that command.exe has a lot of limitations. So Commander allows you to either launch a standard Windows command prompt or PowerShell, and also it supports multiple tabs, which is very handy when you want to run multiple command line tools in different windows. Node.js. It is a JavaScript execution engine on the server side. What makes it more powerful is that whatever code you write on the client side, provided you don't directly deal with the DOM manipulation, you could easily move them onto the server side and run them in Node.js. It's built on top of Chrome V8 JavaScript engine. There's also a pre-release version available from Microsoft, which is built on top of their Chakra Core JavaScript engine. It's gaining popularity amongst the developer community, and there are plenty of modules available for consumption right away. Like I showed earlier, this is clearly the leader in terms of the number of packages hosted at this point in time. If you go to their GitHub site, you can see how many companies and projects and applications are using Node.js. Just to give you an idea, some of the popular companies like LinkedIn, Netflix, and PayPal, just to name a few, are already using Node.js, and many startup companies in Silicon Valley, they just tend to use Node.js because it's very easy to hire developers. They only have to look at JavaScript skill. Of course, they need to be trained on other server-side JavaScript technologies, like how do I connect to databases like MongoDB, and so on. But then the language skill set is easy, because if the developer knows JavaScript, it's easy to train him in Node.js. Unlike in all the other backend technologies where you have to find somebody who's experienced in Java, JTE, or Microsoft.NET, and so on. Now all you need to look for is just JavaScript skill. That's one of the reasons why people prefer to use Node.js, besides the other advantages of Node.js servers and its scalability, and also the support of clustering Node.js and so on. Node.js itself out of the box, can serve simple web pages, but you really need some powerful frameworks to implement REST APIs. And there are three popular frameworks out there, and they are Express, Hapi, and Restify. I've decided to show how to use all three frameworks. So we're going to take our contact manager REST API that we developed in ASP.NET Core in the previous part, and we're going to re-implement that, or implement it from the ground up on Express, Hapi, and Restify. Let's start with Express. Express is a fast, unopinionated, minimalist web framework for Node.js. This is literally taken from their Express.js website, and it is true. To install Express, you'll run the command npm install express, and I'm going to also install body parser now, because without body parser, it would be hard for you to implement the post, delete, and put methods. And then since we're using TypeScript, we need to install the type definitions for Express and all the other dependent modules. So that's, you can see the modules that are required by Express, like DT tilde Express. The DT is a shortcut for definitely typed website. It's a GitHub repository. That's where many Microsoft TypeScript d.ts files are available. So many third-party libraries, JavaScript libraries, and then some open source volunteers, they have put together a lot of d.ts files so that you don't have to create them from scratch. Okay, now let's go ahead and implement a simple REST API in Express. But before we go ahead and implement it, I just wanted to install all the required dependencies of Express. Okay, let's go back into the Commander interface. The first thing that I wanted to do is to create the project folder structure. So let me create a folder. We always start with the folder named tutorial, and we are in part 6. So I will just create a folder structure like this: tutorial part 6 modern Node.js server source. And what I would like to do is I'd like to start at the Node.js level, because that's where I want my node underscore modules folder, where the packages will be brought or downloaded. So let me go into that folder that we just created, not all the way up down to source. We will stop at Node.js. So I'm going to use the cd command to go up to Node.js. And then we'll start installing the prerequisites one by one. The first thing I want to install um, is Node Package Manager. And I would like to show you the website of Node.js because it's very easy. If you Google for it, you can go there and find it. But just in case, you go to nodejs.org and then you download this v6.7.0. You can also use the 4.6.0 LTS. It's lifetime support, and they only update it every now and then. But the current version will keep on updated. They'll keep on updating it whenever they have a new release. I prefer to install 6.7.0. You click on this link and you run the installer. I've already done that, so I'm not going to do that now. So as part of the Node.js installer, you will get npm. So you can type npm dash dash version to check what version of npm you're running. And it's always a good idea to update npm right away using the npm itself. So you can run the command npm install npm dash dash g, which means global. So if you hit enter, it'll try to go and bring if there is any other latest version of npm available. The reason why I'm doing this is npm releases out of band with Node.js. Node.js version might be incrementing slowly, but you might have more npm releases for a particular Node.js version. So it's always a good idea to run the npm install npm globally dash with a dash dash g switch, just to make sure that your Node package manager is the latest and greatest. After this command is completed, what we will do is we will initialize a package.json file, which is where all the packages that you download will be kept track of. That's kind of like a project file. So in order for you to do that, you will be running the command npm init. When you run the command, it's going to ask you a series of questions. Most of the questions will be, you will be choosing the default answer of yes. So instead of sitting there and wasting time hitting Y or enter for every question, you can bypass all of them by running npm init dash y, which is what we're going to run as soon as this npm is updated. Okay, now the npm is updated to the latest version. Apparently the version that I had, which is 3.10.8, seems to be the latest version. Now that we've installed npm, let us initialize a package.json by running npm init dash y, and then it's going to create a package.json file. You can see that the name it shows is the name of the folder. We can edit all of this information later. Okay, now that we've installed npm and created a package.json, it's time to install TypeScript. I'm going to install the latest version of TypeScript, which is 2.0.3, and first I will install it globally, and after that installation is completed, I will install a local version of TypeScript as well, because I want the Visual Studio Code IDE to use my local version of TypeScript. And this flag dash dash save dash dev means that it is a development time dependency, which means that we don't need TypeScript to run our application, because after we transpile the code from TypeScript to JavaScript, we don't need TypeScript compiler at all. So let me hit enter. So it installs locally, as well as it makes an entry under a dev dependencies setting inside of package.json. Okay. Since TypeScript requires type definition files, we're going to install a tool named Typings. Let's install the Typings tool because we will need the type definitions for some of the JavaScript libraries that we'll be using. So let's do that by running npm install typings, and we'll install it globally. And once that is installed, we will create a file named typings.json by running the command typings init. If you notice that all these command line tools have their own JSON file as the configuration file, the idea behind that is if you check them into the source control, when somebody else gets your project and they just need to run the tool space install, and if there is a JSON file specific to that tool is available, it'll go ahead and start installing whatever files we already downloaded and recorded that in the JSON file. To initialize the typings tool, we'll run the command typings init, and that will create a file named typings.json, which is used to track all the type definitions that we download. You can see that we already created package.json, and by running the command typings init, we also created typings.json. Now it's time for us to create a TypeScript project. And a TypeScript uses a file called tsconfig.json, which is like the project file for TypeScript, where we can specify some settings like what is going to be my module type, where should my source be read from, what should I exclude when I'm compiling, and so on. There are quite a few settings in tsconfig.json. So let us initialize our TypeScript project by running the command tsc init, and that will create a file named tsconfig.json, which we can type the content and you can take a look at it. We're not going to stick with these values. I'll be changing them to suit the Node.js project. But for now, that is good enough. Now it's time for us to install the Node.js Express framework and its dependencies using npm install. And we will save them in our package.json with the switch dash dash save. So we'll install the Express framework, and also we will need the body parser module, which is very handy when we want to write the endpoints that support the HTTP verbs post, delete, put, etc., where we'll need to parse the HTTP body. And then we'll do dash dash save because we want to save these two dependencies in our package.json. And after that is installed, we will install the TypeScript type definitions that are required for the Express and its dependent modules by running the command typings install and the name of the modules that is required. There's quite a few dependencies for Express, so I am going to get the command line. So we'll go over the names of the modules. We need Express, we need Serve Static, Express Serve Static Core, MIME, Debug, and Body Parser. If you notice that I used a DT tilde, and DT means definitely typed. That is a GitHub repository where most of the TypeScript definitions are available today. Okay, let's hit enter, and that will download the TypeScript definitions from the definitely typed GitHub repository into our project. If you check the directory listing, there is a folder called typings, and you can do the directory listing of typings folder, and there is a globals underneath that, and that's where you will see all of those type definitions that we brought using the typings install command. Okay, before we start writing the REST API, I would also like to install the modules required for the other frameworks, Hapi and Restify. So first, let me get the Hapi modules that I want, as well as the Hapi frameworks dependencies as well. So we have Hapi and Boom. Boom is a nice framework to throw friendly HTTP error codes and error messages. So after that is done, we will go ahead and install Restify. If you notice one thing, we didn't have a need to run the typings tool. The reason for that is All these latest Node packages, they are using the namespace named at types. So what it brings us is the TypeScript definitions of your JavaScript modules are shipped along with your JavaScript libraries or modules as well. So you no longer have to use a separate tool like typings to bring the type definitions. You can use the npm itself to bring your JavaScript module as well as the TypeScript definitions, which is supposed to be shipped in at types namespace. So this seems to be the new trend, and the TypeScript compiler 2.x will understand the at types namespace, and it'll know to look under node underscore modules slash at types for the type definitions. So this is the new standard, and if the standard is being rapidly adopted by many library vendors, soon we will not have a need for the typings tool. So that's where the industry is heading towards. Okay, now that we've installed the Hapi and its dependencies, let us go ahead and install Restify and its dependencies. Okay, so the Restify has only one dependency, which is Banyan, which is a login framework. So after we install that, we need to bring the typings. It looks like Restify guys have decided not to post their typings in that typings namespace. So no worries, we will get it from typings. Definitely type repository. And the type definitions that we need are Restify and Banyan. Okay, while we are at it, I'm also going to install one more library that will be very handy for string manipulations. It's called Lodash. I will install Lodash and its type definitions as well. The type definition of Lodash is posted under at types namespace, so we don't have to run typing command. So that's going to be npm install Lodash and then at types slash Lodash. Then we want to save it. Okay, once this is downloaded, we'll start creating a project structure, but first we'll start customizing the tsconfig.json. Now that we've installed all the prerequisites for all three frameworks, I'd like to quickly go over what are the other two frameworks. The next framework that we're going to talk about is Hapi. Hapi is another rich framework for building applications and services in Node.js. And we've seen how to install Hapi because we just installed it. And we already talked about that types namespace as well. Then the next framework would be Restify. Restify is a very popular framework, and it only focuses on providing the REST service endpoints. Unlike Express and Hapi, which are full-blown web framework, which you can use to serve web pages as well as REST service endpoints, Restify is only dedicated for REST service. To install Restify, we know the commands, we already installed it, and we also installed the type definitions of Restify and Banyan, and we also installed the Lodash. So now that we've done all the prerequisites install and we just look briefly about what each framework is all about, let's launch Visual Studio Code and start editing our tsconfig.json file to suit our requirements. Okay, so let me launch Visual Studio Code by typing code dot. And then after it's loaded, I'm going to maximize that and then zoom it up a little bit. And the first thing we'll do is to look at our tsconfig.json and make the required changes to compile the TypeScript. So what I'm going to do is I'm going to change some of the settings. I'm going to bring the settings from my completed project and I'll explain the main changes that are interesting to us. Okay, here we go. Okay, the first thing we want to do is we want to change the target to ECMAScript 6 because we are going to be using the import statements and we want to transpile our TypeScript code into ECMAScript 6. And then we're going to use the module resolution as the node's module resolution because it's a Node.js application. It makes sense. And then we're going to generate the source map because when we want to debug and put breakpoints from our TypeScript application, we need the underlying JavaScript and source map that connects the JavaScript files with the TypeScript files. So that way the debugger can easily hit the breakpoints without any problem. And then we want to exclude the node underscore modules because we don't want to compile the source code under node underscore modules folder. Okay, so now that we've made changes into the TS config, it's time for us to create a TypeScript task runner. That way we don't have to go outside of this Visual Studio Code and run the tsc-watch command to watch the changes. So I'm going to just do Control-Shift-B, that is the shortcut key, and then it's going to say no task runner configured, that is correct, and we are going to click on this configure task runner button to create a TypeScript tsconfig.json task runner, and that's going to create a file named tasks.json, which is being used by VSCode. That's why there's a special folder named .vscode, and we'll be adding more and more JSON files under this .vscode. These are all very specific to Visual Studio Code. And if you can look at it, it just says that run this command tsc, and these are the arguments, which means that run from the current folder and start compiling or transpiling all the files in that folder. That's pretty much it. So what we want to do now is we want to create a simple TypeScript file, and then we'll see that this tasks.json transpiling that file. Okay, so let's expand server source, and let's say we'll create a simple index.ts file. So we can just say export class. I'll come back to that warning later. Export class, index. Let's not do anything, just a simple class. And let's save this file and let's switch back to the warning. It says the info. The workspace folder contains TypeScript version 2.3. Do you want to use this version inside? Yes, we can say use this version, and it's going to start using that version. As you can see, as soon as I did that, it showed the TypeScript version at the status bar changed to 2.0.3. And actually, there's a small trick to that. You can always make sure that it is going to use this version by adding a special file called settings.json file. So in order for us to do that, we'll just create file, preferences, workspace settings. And then what we want to do is we want to mention that the TypeScript.tsdk setting will have to always go and use the TypeScript compiler under node modules TypeScript lib. This way, it's always guaranteed that it'll always pick up the TypeScript version that we locally installed. So this is the way to tell Visual Studio Code's language service to use the local version of TypeScript. So that's another way. So now that we've done this, let us start transpiling. Let us do a Control-Shift-B, and then you can see that it'll start transpiling. Okay, look at that. So the index.ts has generated index.js and index.js.map. Well, it is good, but it looks messy because we don't want to see the transpile files. And so there are some tricks to hide them. I'll show you two tricks, two techniques. The first one is to hide the files using settings.json, and then we will actually do the real world implementation, which is to create a separate folder called dist, which is called distribution folder, where I'd like to keep the transpile files stored in the distribution folder, and then the source file will be clean with only the TypeScript files. First, let us see how to hide it. Then we will we'll talk about how to generate the transpiled files into a different folder. In order for us to do that, we have a setting called files.exclude, and it's some mapping. So all it does is it just says files.exclude, and then we're checking star is a wildcard character. I don't care. So the base name is the base name of the file, which is index. If there is an index.ts in the file, then exclude the map and the .js. Anything that ends with .map and .js should be hidden. So that's what you want to do. And then when you save this, you can see that immediately the files have been hidden. They are actually in there. If you go into the Explorer, you will see them still sitting in the folder. but it will not show up in Visual Studio Code. As you can see, you have the index.js and index.js.map file, but then they are not shown in the VS Code because VS Code respects these settings. This is good for to start with, but then I really don't like this approach. So what I'd like to do is I'd like to go and add the out dir setting into my tsconfig.json that will generate the transpiled output into this specific folder. So I'm going to call it server/dist. And before I do save it, I wanted to create that folder so that it'll be available for us. And then as soon as I save it, and then I have to trigger the compilation. As you can see, the compiler is watching, but then I didn't make any changes. So I'm just going to go here and I'll just make some changes, edits, and then I'll save it. And as soon as I save it, you can see that the file change is detected, and then it starts compiling. Now, if you go inside the distribution folder, you should see the generated files. But let me go back and check the config.json. I did say outer equals server/dist, and that folder is available for us. Let me stop the running task, and then we will run it again and see if that works this time. Okay, so I've kicked the build process. Yes, we had to stop and restart it because it's a change in the out there. So we wanted to pick up the tsconfig.json all over again. So now that we have this index.js generated in the dist folder, it's cleanly separated. The source file has the TypeScript source code, and the distribution file distribution folder has the JS and JS.map. So let me go ahead and delete these unwanted files, and let's go back and look at the dist file. As you can see, there's an index.js and index.js.map. The reason why the .map is not shown, I think, is because of this settings.json, because it hides the base. Now the base name became index.js, so the index.js.map is not being shown. Now that we've been using this dist technique, I think we can remove this. I'll just comment this out, and I save it. Boom. Now you see the index.js.map is being shown there. Okay, so let me remove this comma. And I think we're all set with the TypeScript project settings. Now let's configure our Node.js launch settings. In order for us to do that, we need to go back into this debug, and then we need to set up a configuration. We will configure it to use Node.js. Because I click run, since there is no configuration, it's asking me to configure an environment, and I'm going to choose the Node.js as my environment. Okay, so now it's not going to work magically. We need to make some changes to make sure that it points to the right folders. So here are the changes that I'm going to make into this launch.json. We want to start with workspace root, which means the folder from where we launched VS Code, and then we have a folder named server underneath that, and then we also have a source folder underneath that, and we are going to start. We're not going to be using index.js. Rather, I would like to start with node-server.typescript. I'll explain you why we need to launch with the TypeScript. Only then you will be able to set breakpoints. If you're going to start with the distribution folder and then the resultant transpile file, then it is not going to pick up the debugger is not going to pick up your breakpoint. So you must start with the TypeScript file that is the entry point of Node.js application. Okay, and then we want to leverage the source maps, otherwise it's not going to work. So I'm going to bring the source maps, and also the out dir must match the same thing as well. So you have to give the exact same path to the out dir. So I'm going to say workspace root /server/dist, that is our out dir folder. With these settings, we're all set. Now let's jump into writing a simple Express application, and then we will just have a simple endpoint that can be accessed via HTTP GET verb. Since we'll be creating this application class in 3 frameworks, that is Express, Hapi, and Restify, Let me define a TypeScript interface for those three application frameworks. Let me create a folder structure. Since we are defining the REST API for a contacts manager application, I'm going to create a folder named contact-manager. And then underneath that contact manager folder, I'm going to create a new folder named Bootstrap. That's where I'll put all my application classes and this interface as well. Let me create an interface named inode.js-application.ts. And the interface is going to have only one method, which is called Bootstrap, and it's going to take a port number as an argument. As you might have guessed, that this will be the contract for three frameworks named Express Application, Hapi Application, and Restify Application. And whatever the port number we pass as an argument, that is where these application frameworks will start listening for HTTP requests. Let us define an Express Application class, which is going to implement this interface named iNode.js application. The first thing we want to do is to import the required Express modules. We will do that by importing the required modules, and we will start using them inside of the application. So we will get Express, debug, HTTP, and also the interface that we just defined. The name of the interface is iNode.js application. Then we will implement the class, and the class will have two properties, and they are of type express.application and express.router. So let me get the source code from the completed application, and I will copy and paste that code, and let me close the curly brace. So the name of the class is going to be express application to indicate the framework that we're using that implements the iNode.js application, and we defined two properties named express application and contact router, and they are of type express.application and express.router. Let's define a constructor now, and inside the constructor we will be creating an instance of these two properties. Let's create a express.js application and an express.js router. Okay, so the express method returns an express application, and the express.router function returns the router express.router instance. And then we're going to define two helper methods. They are called config error routes and then config API routes. Let me bring in the definitions of the config error routes. It's a private helper method, and then I will invoke that method from the constructor. Okay, as you can see, I'm using the express application dot use function that takes a callback function, which takes an error, a request, response, and the next, which is like a function to the next function in the pipeline. So the message that we display in the console is invalid URL, and we also send the response HTTP status code 404 when this config error routes method is invoked when there is any error. The next method is called config API routes, and inside of that we'll define a get method that will listen on a given port, and then when you call the API method, it'll return four hard-coded contact values as a JSON object. So here's how it looks. Since we already constructed it, I don't need the duplicate construction. And the contact router, which is of type express.router, has a route function that defines the URL segment. And when this URL segment is hit with the HTTP get verb, that is what we that's what we notify the express application using the .get method. Similarly, for post, it'll be .post and .put or .delete and so on. So the get method takes two arguments, a function callback that takes two arguments, express request and express response. And inside of that, what we're doing is we're defining a helper method called getID, which is used to increment the ID for the primary keys of contacts. And then I'm defining four hard-coded contacts, and I'm returning them using the response.json function, which serializes the contacts array as a JSON object. And then at the end of it, we're also using the express application.use, and we define the URL segment as /API, and we define the contact router to be used when /API is used. As you know, you already have this base URL of /API, and also this contact router has defined the segment /contacts. So what it does mean is the final URL would be like this. If let's say, for example, we're going to be using port 8080, so it's going to be like http ://localhost 8080. The base URL is API, and the URL segment where the router is defined is contacts. So when you hit this URL, you're going to get into this function .get, and then it will return these 4 hard-coded contacts. It's that simple. Okay, now that we've defined the config API route, let us call that method from the constructor, this.config API routes. Okay, now we have to define the bootstrap function. The bootstrap function is the function that is defined in the interface Node.js. So that is very important function. Let's define that as well, and we will copy and paste the code from the completed application. Let me explain what this method does. The first thing we do is we set the port to a given port argument, which is going to be passed as an argument into the bootstrap method. Then we'll create an instance of the HTTP server by calling the http.createServer, and we pass our express application as an argument, which is going to be the listener. And then we call the server.listen function with the given port number, which means that by now the Node.js will start listening on the given port. And then we define 2 handlers, an error handler and a listening handler, and they are pointing to the helper functions that are defined within the scope of this bootstrap function. This is done to avoid polluting the class namespace or global namespace, and it's perfectly valid. In JavaScript, you can define functions within functions. So we're going to be calling, when there is an error, it'll call the onError method. And the things that are really of interest to us is this switch case statement, where we check the error code. If there is no privilege, it says requires elevated privileges. And if the port that you are passing as an argument is already in use by another web server like Apache or Tomcat or anything, then it's going to throw an error. So make sure that whatever the port number you're going to pass inside of your launch.json, where you have an environment area, here I could say port colon 8080. So this is how you pass the parameter. So okay, so if you pass it, it'll take the value. If you don't pass it, it'll default to 8080. I'm just passing 8080 as an example. And you can pass any number of port, any port you want, not any number of ports, any port number you want. So that's what this onError method is. OnListening is simply going to use the debug function call to get a debugger for the Express application. You can give any string you want. Since my application's name is Express application, I'm passing that as an argument. And using that, you can display some message on the debug console. It's going to say listening on port 8080 if you pass 8080. That's about this Express application class. So let me save this, and then what we will do is now we need to define the entry point. If you remember, we just played with the index.ts class, which is not the name that I want. I would like to call this as node-server.ts, because that's what we gave as the program to launch in our launch.json. If you notice it, workspace root denotes the folder from where we launch Visual Studio Code, and then there's a server folder, it goes there, and then there's a source folder underneath that. It is looking for node-server.ts, which is what we're going to define now. So let's go back and define that class node-server.ts, and in here what we do is we first import the Express application from this path, and then what we're doing then is we have a constructor that displays a debug message. Then the helper method named normalize port, which will pass a string as an argument, and it'll parse it as an integer, because a port has to be an integer. And then if it's an integer, it works fine. Otherwise, it's going to throw false. And here comes the bootstrap function, which is the main entry point function for our node server. And then there you check if anybody has defined an environment variable named port, in launch.json or from command line. When you do that, you will just say node space. You will give those variables. Since we are using launch.json, this is where I mentioned the environment variables. And I defined the port 8080. So it's going to check that value. Since the value is there, it's going to use that. If it is not there, it will fall back on 8080. Similarly, I'm defining another variable. I'm checking if there's another environment variable named REST framework. If it is defined, it's going to use the value. If it is not, it's going to fall back on express. We are not yet ready to use this variable, but it's still there because we're going to add the code later to check if there are other frameworks like Hapi or Restify that are specified in the environment variable. If so, we will look for the Hapi application or Restify application. But for now, since we are just developing this application, I specifically said server equals new express application, which means that I'm not taking advantage of this variable yet. Then I call server.bootstrap, which will enter into the bootstrap function that we defined here, and it'll follow the flow will go from here, and it'll start serving and start listening on port 80 and 8080, and then we can launch the browser and we can hit localhost colon 8080 slash API slash contacts, and it'll hit the get method and it'll serve those 4 hard-coded contacts. You can also use any other tool like Fiddler or Postman or Advanced REST Client. It's your choice. For this demo, I'll be using the browser since GET requests are easy to send from the browser. And then that's only the class definition. The class is not going to magically run. So we need to create an instance of the class, which is an object node server equals new node server. And then we call node server.bootstrap. Let us save this. I don't see any compiler errors. Since there are no compiler errors, if you go to the dist folder, you will see that they're all, they're not built. So let me do a control shift B because I've stopped the build. So if you do a control shift B, it should start building. Yep, it built, and then you can see that it generated the JavaScript and JavaScript.map file. Now that we have defined our node server as well as Express application, let us start the debugger by putting a breakpoint here, hit F5, and it'll launch the debugger. Let's check why we are getting an error. Okay, it looks like a path problem. Let's go check the path. We are in source. There is a contact manager. I think I spelled it correctly. Then there is a bootstrap. Instead of bootstrap, I typed bootstrap. Let me add a T, and that will solve this problem. It's a typo. So let me go into the dist folder to make sure that it picked up my changes. Let me go into Control Shift B, and we will check. We'll have to refresh sometimes. It may not refresh. Um, Let me refresh one more time. Okay, uh, let us recompile it. Let me terminate this and then start again. Yes, now it created the bootstrap folder. So what we would like to do is, since this is a typo introduced by me, I'm going to delete that folder because it's useless. I'm going to delete that. Okay, so now that we have everything transpiled successfully, let me hit F5. It's going to launch and hit the breakpoint. So if you notice it, we are seeing this output window. You can see that using Control Shift U. And if you do it one more time, it'll toggle. But what we want to really see is not the TypeScript compiler output, rather the debug output. So in order for you to get that, go into Control Shift D. Go into this debug, and then you have another option to bring that window. So that is this guy. Click here. Now it shows the debug console. So let's hit F10. Let's hit an F11 to step into the bootstrap function. And then as you can see, it hit the constructor and it printed the node server constructor message, which we have already included here in console.log. And then we're going to call the normalized port. Since we've defined the environment variable port, it is being passed the value of 8080. It's coming from this launch.json environment variable named port. So let's go back and hit F10, and we're parsing it. Since it's a valid number, it's going to return that successfully. So the port is 8080. Since I haven't defined any environment variable named rest underscore framework, it falls back on express. And since I'm not going to use it, it doesn't matter. So I will call this constructor. If you hit F11, you can see that the control goes there. Create an express application, express router, configure error routes, configure API routes, and then we call the bootstrap function. It's going to create the HTTP server, start listening on the port, define the error handler, listening handler, and it is waiting for our input now. But before we hit the browser and give the URL, I'm going to put a breakpoint onto the get method just to make sure that we're hitting the get function. I'm going to put a breakpoint over here. Okay, let me go launch browser, and then I'm going to hit the URL http://localhost 8080/API/contacts. Hit enter. You'll hit the breakpoint. Oh, we're getting an error. Let me. Oh, I know what's going on. I just rebooted my computer, and since I have XAMPP running, we are getting a problem on that port. So I'm going to go back and then turn that XAMPP, which is running on port 8080. Yes, Apache is running on the port. I'm going to stop that. Sorry about the confusion. And once that is stopped, we will start listening on port 8080. Yep, and it hits the get method, and when you hit F5, we're going to get those 4 hard-coded contacts as JSON array. That is how we define an express application, and we define an abstraction named node server and make the node server use the express application to serve on port 8080 using the URL segment /API/contacts, because we defined the express router to listen on that particular URL segment on that port. Okay, now that we've done that, it's time for us to do some more refactoring, because there's um, lot of code inside the get method. I don't like to have too many lines of code inside of my route methods, so we'll refactor them out into its own repository, which we've already done in the previous parts. If you've been following along this series, there are 5 parts that are already uploaded. I already uploaded into YouTube. There, what I've done is I've created a repository class and a model class related to the contact manager on the client side. One of the beauties of Node.js is, since it's also running on JavaScript, we can take the client side code and move them onto the server side. We'll see how we're going to do that shortly. Now let's organize our project for a cleaner separation. So what I'd like to do is I'd like to introduce a few more folders underneath the contact manager. The first folder would be called DI, which is very specific to host the dependency injection specific classes. I wouldn't be talking about dependency injection in this section, but in the next section, we will talk about that in detail with examples of how to use Aurelia's dependency injection container on the server side inside of Node.js. Then we have the models folder. Instead of creating a single application class and bloat the class with our API implementation methods, routes, etc., I'd like to take them out um, and reuse the client-side model and repository that we created in the previous parts of this tutorial series. So that's where we'll keep the model classes required for the API. The routes class, the routes folder obviously will have the routes to match the HTTP verbs like get, post, put, delete, which will be used for creating the CRUD operations, which is create, read, update, delete operations. And the services folder is going to have the actual service interface and the classes used by our API endpoints. With that said, now let's go back to our project and keep adding all these folders. Okay, so let me go back into the contact manager folder. Let's start creating the folders one by one. So I'm going to create the DA folder, which I will not be, where I will not add any files in this section. Then the next one is going to be models. I want to make sure that it is at the contact manager level. Then we will also have the services folder created. Oops. I want to click on the contact manager, so it's always created under that. Okay, the first thing we want to do is add a model that represents a contact. As always, we'll be using the TypeScript interface to create that model class. So I'm going to call it iContact.ts, and I will copy the code from the completed project. Okay. So this model represents the fields that we'll be using in the contact manager, like ID of the contact, first name, last name, email, phone number, birth date, and a thumbnail image, which is I put a question mark to indicate that it is an optional property. So I will not be using that in this section or in the following sections. When we have a future section where I will be showing how we can upload images from the client application and then store them on the server side. So we'll talk about this thumbnail image property later. After we created the contact, now it's time for us to create the interface for the contact manager. So I'm going to call that iContactService.ts to indicate that it's a TypeScript file, and that interface is going to define the CRUD operations. So first thing is we're going to import the iContact that we defined in the models folder. And then in iContact service interface, I'm going to have the get all method, a get method that will return a contact based on the ID of the contact, and then a search method which will take the keyword. And in our search implementation, we're only going to be searching the first name and last name properties using a contains search. And then the save, as always, will save the contact or whatever edits you made, and then it will store it back into the in-memory repository. And then the create method will create a new contact, and delete will delete the contact from the in-memory repository based on the ID of the contact. So these are the standard CRUD operations that we use in any application that requires you know the CRUD operations are very important for any application. So, basically they'll query something, they will create something, they'll delete, and they will search. Search is also called query. And then we'll edit and make some changes to the existing data. Those are the standard operations in any form-based application. And then we will have a concrete implementation, and I'd like to call that um, in-memory contact service. Okay, so I'll bring the code first and I'll explain them one by one. So in here, the first thing we want to do is to import the interfaces for the model and for the service. And then we are on the client side. I was using a promise, and then there are many promise libraries, and ECMAScript 6 has promise libraries out of the box in the browser itself. But what I would prefer to use is a Bluebird promise library, which is a very, very good promise library. So I'm going to use the same thing. Since I've used this on the client side, now I would like to use the same library on the server side as well. So line number 3, I'm just going to say var promise equals require bluebird, which means that I'm going to use the bluebird promise library, and that module is going to be imported into a variable named promise. And then the latency here is used to introduce the fake delay, because this is an in-memory repository, so there's not going to be a over-the-wire delay, or there is no database lookup where there will be some latency. So what I'm doing is I'm introducing an artificial latency of 200 milliseconds. And then I start the ID with 0, but then if you notice that the first thing it does is it increments using the prefix plus plus operator, which means that the IDs will always start with 1. And then I define a small helper function that's going to just keep on incrementing the ID. And then I define 4 hard-coded contacts, and it will start with ID 1, and then it goes to ID 2, 3, and 4. And that defines the array that I'll be using for this in-memory contact service. Then we implement the class in-memory contact service and implements the iContact service interface. The first thing that we want to look at is the get all. Get all is going to return a promise, and then what we are doing is we are using that set timeout method to introduce that artificial 200 millisecond delay, and all we do is we just assign that context array and then we'll resolve the promise. So that means the client who is waiting on this promise will get a success, and then it'll return the context array to the caller. We will also take a look at how we're going to rewire the Express application and also the other frameworks like Hapi and Restify. After we introduce this in-memory contact service, we will leverage this in-memory contact service from all three frameworks so that their HTTP methods like get, post, put, and delete, they don't have to do any heavy lifting. They'll just delegate the call into the in-memory contact service. That's the plan. The next method that is of interest is get based on an ID. Again, we do a is requesting equals true. What we're going to do is this is being used, will be used by the user interface to make sure that if there is already an AJAX request in progress, then this will not make another request. So that's the idea. So we want to just introduce this is requesting flag for the progress bar to be displayed on the client side. When we bring in that client side Aurelia project and integrate with this Node.js project, or maybe in section 2 or 3, I'll show you how this is requesting is being leveraged. That get method is also using the same set timeout to introduce the artificial delay. I'm not going to repeat that for every method, so please understand that this 200 millisecond is only an artificial delay or latency that we introduced. And then we are using the dot filter, which is again an ECMAScript 6 feature, and then we pass a lambda expression. All it does is it checks, hey, if the ID is equals to the ID that we pass, then it could return technically an array, and then I'm just getting the first element out of that, and then I check if the value is found. That means it's successfully resolved by using this cool technique of parsing and then stringifying the JSON. This is kind of like the object.cloning deep clone shortcut. We just use the JSON library to do that deep cloning. Else we'll just say reject method, which is going to indicate that it's a failure, and it's going to return the message contact not found because the ID that we passed is not in the array. Then we say this dot is requesting equals false to indicate that the request is completed. So that's the implementation of the get method. Similarly, the search method is also going to use the filter. As I told earlier, it's only going to look for the first name and last name, and also checks if the keyword is containing in the keyword is inside of first name or last name. So it uses the contains check by using the index of method, and then it resolves if there are any results, and then it returns it sets the is requesting equals false to indicate that the AJAX request has completed. Similarly, for the save, we do the same thing. We first get the instance by using the JSON shortcut, and then we check if the contact is found by using the contact.id. We are checking that um, we are checking if that contact is in our in-memory repository, that is in-memory array. And if it's found, then we get the index of that, and then we overwrite that with the newly created or the contact that we want to save. If it is not found, what we are going to do is we just create a so if it is found, we replace it. If it is not found, what we do is we push it because it's like a new contact, but we need to fill the ID first. We call the get ID method, which always tracks the lastly added contact's ID, and then it's going to increment that by one. So we cover both the scenarios. We push a new contact if the contact is not in the in-memory repository, but if it's already there, we replace it. So that's the idea here. And then we resolve the promise. Create is very straightforward. Create would always create a new contact, which means that we'll set the ID and then we'll set all the properties to their default value, and then we push it to the array. These are some helper methods. The get contact index is going to wrap up the find index method and returns the contact index, the index where this contact is inside of the array. Delete method is also going to do the same thing. It uses the filter method based on the ID to find the contact. If it is found, then it is going to it is going to use the splice array helper method to delete that contact from the array, and then it returns what has been deleted. Otherwise, it's going to simply reject the promise with contact not found. So this is a very straightforward in-memory implementation of the contact service. Before we attempt to run any of this, we need to make sure that we have installed the promise library, the Bluebird promise library. So what I'm going to do is I'm going to use the npm install command. And luckily, the Bluebird library is also shipping their types in the npm at types namespace, which means that we don't have to run the extra typings command. So what I'm going to do is I'm going to run the npm command to install the Bluebird library and the Bluebird library's TypeScript type definition files. So once this is done, what we'll do is we will take a look at how we can refactor our Express application to use this in-memory contact service. Okay, now that the Bluebird promise library is installed along with its type definition, let's go back into our Visual Studio Code and then start refactoring our Express application class. Okay, the first thing that we want to do is we want to bring that in-memory contact service and the iContact models, both of them. Let's bring the interface and also the in-memory implementation of the repository or the contact service as we call. Okay, so then the next one that I wanted to do is I want to declare a property for the in-memory contact service. So I'm going to call that as contact service, which is of type in-memory contact service. Okay, then we will create an instance of that by using the new operator. I'm going to say this dot contact service equals new in-memory contact service. Now let's go into the implementation of the routes. And instead of having this big hard-coded helper method, which is now being wrapped by the in-memory contact service, we will just delete this implementation and start using the contact service, in-memory contact service. So it's going to be that simple. Um, Let me look at that and then delete the whole thing. So we're going to delete this up until this. Then what we'll do is we'll use the contact service dot get all helper method. Okay, so now what we do is we just call the contact service dot get all method. Since that returns a promise, we use the then method and then we just get the contacts as an array. I declared that as a type of iContact array, and then what we do is we return that using the response.json of contacts. So that is very simple. So we moved the entire implementation of the get method into a in-memory service, and then we just create an instance of the service and we call the get all method. Um, Let us also get the body parser as well, because like I said earlier, we need the body parser if we were to implement the put, post, delete method. So it's a good idea to bring that into the system now, into the um, Express application, and we will use it later. So then what we will do is inside the config API routes, what I would like to do is I'd like to start using that body parser. So I'm going to just say this .express application .use of slash API where we have the contact router defined, and then what we wanted to do is we wanted to also set the body parser as well, so that we'll have the body parser available for us. Okay, then we will try to run the application now to make sure that all the changes that we made are working. So let me save it all, and then we'll do a build by pressing Ctrl Shift B, which is already there. I think we don't have to terminate and rerun it because the compilation is complete and it's watching for file changes, which means that whatever code that we brought in has no compiler errors. Now let's go back into this debug pane, and then we'll start hitting the run button. So the Node.js will start, and we can start hitting the localhost 8080 slash API slash contacts. All that we've done is we've just used a helper contact service class now. So the result should still be the same. So let me bring up a browser window and let's hit localhost 8080 slash API slash contacts, and it should hit the breakpoint. And now it'll go into the contact service. And as you can see, it's going to return the array, which is going to be returning the same for hard-coded contacts. So what we've done is we've just separated the implementation from the get method into its own in-memory repository, also known as in-memory contact service. Okay, so now that we've done this with the Express application, it's time for us to focus on the other frameworks like Hapi and Restify. Okay, now we will switch our attention to the Hapi framework. What I'm going to do is I'm going to open up the Bootstrap folder and I'm going to create a new application named happy-application.ts, and I will bring in the completed source code for the Hapi framework, and I'll explain that config error routes and config API routes method. Okay, so let's take a look at the imports. As we know, the Hapi and Boom are the important modules. The Boom module is used for changing for returning the HTTP error codes back to the caller. And then Node.js application, which we know is already an interface, and iContact and in-memory contact service are exactly the same that we used in the Express application. So the Hapi application requires a Hapi application, which is of type happy.server. The happy.server class has the wrapper for a Hapi application, and this contact service is the same as in-memory contact service. We display a friendly error message to indicate that it is that the code has hit the constructor, and then we create a new instance of happy.server. In the Hapi application, we have the ext method to set up the extension or error handlers, and we have an on pre-response, which is called right before the server sends the response back into the client, which takes two arguments, which is a type happy.request and happy.ireply, which is an interface. And then we check if the response is boom. Is boom means there is an error, and then we check if the request.response.output.status code equals 404. This is a dynamic property, and the typing's definition is a little out of sync. That's why you see a red squiggly, but you can safely ignore that, because at runtime, when I put the breakpoint and put the mouse pointer over there, you will see that there is a valid value in the output property of request.response. Then we display a friendly message saying invalid URL, and we also throw the 404, which is the boom wrapper has a not found helper method with the special error message that is called check your URL. We can put anything you want, but I said check your URL. You can call whatever, you can just throw whatever message you want there. Then we call the reply method with the response. If there is no error, we just call the reply.continue, which means that it'll go into the next one in the pipeline. So that's how we configure the error routes in Hapi. On the config API routes, we need to define an endpoint. The Hapi application uses a big JavaScript object. So first you need to specify the path, that is a URL endpoint. Then the method, HTTP method, whether it is get, put, post, delete. And then the handler takes a request and response. And then here what we do is we just make the call into our in-memory contact service dot get all, and then since it's a promise, we use the then resolve method, and then we get the contact array and call the reply method, so it sends it back into the caller. So this is a simple implementation of a get endpoint. The bootstrap method we already know. In Hapi application, we have to call the connection helper method, and then we have to pass the port as an argument, and then we configure the error routes, we configure the API routes, and then we call the start method, and on success we just display, hey, I'm listening on this particular port or in particular URL, which is available in the info properties URI property of the Hapi application object. So this is a simple Hapi application. That's it. Kind of there's a lot of similarities between Express and Hapi in terms of how they are configured, but then the method names are different. And here, for example, there are no special route classes. Rather, we have a route method which takes a JavaScript object or as an argument. Okay, now that we've done that, we can save this, and what we could do is we could let's stop it and make sure that we can request the Node.js to use this framework by adding that environment variable. We'll go into the launch.json, and then where we will add the rest underscore framework environment variable, and we'll pass the value of happy, and then we'll go into node server.ts and see we haven't wired that variable, so it's time for us to wire that. So let me go back into the node server.ts, and let's add a small piece of code that will check the REST framework variable instead of always hard coding it to express application. So I'm going to introduce a small switch case statement, and I will use that switch case statement to figure out what is the value of this variable, and then based on the REST framework variable we will call the appropriate application. The reason why we see the red squigglies, we haven't imported those applications yet. We haven't defined the Restify application yet. So for now, what I'll do is I'll just comment this out, and once I add the Restify application, I'll just bring it back. So I'm going to just comment this, and then I'm going to import the Hapi application that we just defined. So we'll go to the top, and we'll add the import statement for Hapi application right out of that. Okay, now we can put a breakpoint here, and since we already added that environment variable in the launch.json, we should be able to run the application and see that Node is picking up this REST framework environment variable. Okay, let's hit run and wait for the breakpoints to be hit. Okay, so we'll go into the Node server bootstrap method, and we can check the REST framework value. That's happy as expected, and then it's going to go into the case happy, and it's going to go to the constructor, and we'll see the message happy application constructor. If you look at the output in debug console, yes, it printed happy application constructor. And then what we'll do is we will set a breakpoint inside the get method of happy application. So when we hit localhost 8080/API/contacts, instead of going to the happy application, this time the control would go into the instead of going to the express application, it will go into the happy applications get method now. So let me go into the happy application and put a breakpoint in the get method right here. Okay, let me click go. Let's go back to the same browser and then hit refresh, and this time it's entering into the happy application, as you can see, and it's going to call the same in-memory service, and then it's going to return the JSON value back into the browser. Oops, there's some error. It says cannot read property get all of undefined. Okay, let's see if the contact service is being constructed. Uh-oh, we haven't constructed the contact service. That's why it's giving a null reference exception. So what we'll do is we'll just add the um, construction. We'll just call this dot contact service equals new in memory contact service here, and then we will restart, and then we'll run the application again. We'll hit the browser, we'll hit the endpoint, we'll do a refresh, and then this time it has some value because it's being instantiated, and it should return the JSON value back. Yep. So this is a simple happy application. Now that we've done the happy application, it's time for us to move into the Restify framework. We'll create a new class called Restify application, and then we will define the exact same get endpoint. Okay, so let me go back into the Bootstrap folder. I'm going to create a class named Restify application. I'll get the code from the completed application. Okay, in here we do the same thing. I just want to make sure that in the constructor we create a contact service, because that's what we missed when we did the Hapi. So I'm not going to do that. So I'm going to make sure that it is constructed. Okay. Now let's look at the constructor. So in here, technically we should allow the course cross origin resource scripting, because we are running on port 8080, and our client application is running on port 9000. So we will set up the course headers on Express and Hapi later. But in here, I already set up for the Restify application. So first thing is we call the create server to create the Restify application. Then we allow the course headers. Then we also call the helper method restify.course. And we also have a few use methods called pre.sanitize path. It does some cleanup of the HTML, and the sorry, it does the URL encoding, and accept parser. We call the body parser, query parser, authorization parser, full response. These are all different helper methods that are used to set up the Restify application properly. As the name itself implies that the body parser is used for parsing the body. HTTP body query parser is to parse the query string. Authorization we really don't need, because we are not really parsing the authorization headers, because we haven't introduced the authorization and authentication yet. And the full response is always going to be useful for sending the response back into the application, into the client. Um, so that's how we set up, and these two are the standard helper methods: config error routes and config API routes. In Restify application, we have the on function, and then we are saying not found is the error handler. And then we just say that if that URL is not found, then we'll display a simple invalid URL on the console.log. We create a custom error using the error object, and then we send the 404 and the custom error object that we created back into the browser or the caller. Then we move on to the next function in the pipeline. It's the same. It's the same pattern that you've seen in the other frameworks like Express and Hapi. For the API routes, we have the get helper method. The first argument is the endpoint, which is a string URL. And then the second argument is always going to be the request response and the next function in the pipeline. Similarly, like we did in all the other frameworks, here also we are going to call the in-memory contact service dot get all, and then is going to be the promise resolving function, and it's going to get the contact array and then return as a JSON using the response.json method. And similarly in the bootstrap method, we have a dot listen and then the port, and a lambda expression that says that I'm listening on this port. So it's the same, pretty much it's the same pattern for all three frameworks. Now let's go back into the launch.json, and we'll also change this framework to call Restify instead of Hapi. And then we have remembered to go back into Node server. We need to import the Restify application, and then we will uncomment that switch case statement where we had checked for Restify, and then call the Restify application. We need to uncomment that line. Let's go back into that function, and then we will do a control KU to uncomment that. Now let's go ahead and put the breakpoint in the Restify applications get method. So we can rerun this, and we can hit that same endpoint from the browser, but this time we will be using the Restify framework to serve our request. Refresh. Okay, so now we are entering into the Restify application, and we are calling the same same in-memory service, and returns a promise and assigns the JSON. If you want, you can put a breakpoint here, and you can hit F5, and you can see that it comes here, and then you'll see the hard-coded 4 contact array. An array of 4 contacts is returned back to the caller, which is the browser in our case, and you'll get the same JSON. Okay, so now that we've covered all 3 frameworks and wired them in Node server, it's kind of ugly still, because we have a switch case statement. Switch case statement is going to get overwhelming over a period of time. So there is a nice design pattern for it called a class factory. So what I'd like to do is I'd like to introduce a class factory, and inside the class factory, I will just create these applications based on the argument to the create method. So what I'll do is I'll create a class factory that wraps these three applications. Since they are all interface based, it's ideal for class factories. A class factory will define an interface, but it'll create so many concrete instances of that implement that interface, and then based on the caller request will return the object of that type that they're requesting. For example, in our case, the create Node.js framework helper method could take the REST framework that we are reading from launch.json as an argument. And if somebody asks for Express, we could give an instance of Express application. Or if somebody asks for Hapi or Restify, we give an instance. So the job of the class factory is to supply the instance of the concrete implementation based on the input, which is going to be the name of the framework in our case. Okay, then let's go and create a class named Node.js framework factory.ts. So I'm going to go into the bootstrap. I'm going to call the name of the class is Node.js framework factory. Okay, and I'm going to bring up the completed source code. As you can see, I'm importing those three application frameworks, and we've installed the Lodash, which we talked in the prerequisite section. The Lodash has some good string manipulation functions which are going to leverage here. So in the constructor, I display the standard message, which is inside whatever the Node.js framework class constructor. Then I'm creating an array of framework instances, and I use the express space application key for the Express application, Hapi space application for the Hapi application, Restify space application for as the key for Restify applications. I create the three frameworks or the three application instances based on the framework. Then when the caller requests by calling the create Node.js framework and passes the REST framework as an argument, and as you can see, we are going to simply pass Express or Hapi or Restify. I'm using the Lodash's helper method called start case, which is going to take the value that we pass, and I'm using the string interpolation. $REST framework will substitute whatever the value we pass. For example, if we pass Express, it's going to be replaced with Express space and the hard-coded string application. So any value that we pass from launch.json, like if it's Restify, the key will become Restify space application. If it's Hapi space application. If it's Express, it'll be Express space application. So that's the idea. So we'll use that to construct that key, and we'll return that framework instance. Okay, if no framework is being passed, that means we always fall back onto Express space application. So that's the default. Okay. Now we'll see how we can wire this framework or the class factory into our node server so we don't have to use the switch case there. So I'm going to go back into the node server.ts. We no longer have to import this because those are all taken care of by the class factory. So now it's enough if we just import the class factory. So I'm going to import the class factory, which is called Node.js framework factory. So I'm going to just import that. And then what I'd like to do is I'd like to delete this hard-coded switch case statement. I'm going to delegate that call into the class factory. So let me select all this and replace this with a simple call to Node.js framework factory. We need to declare a variable property of that type, and we need to instantiate that. So that we will do in our constructor. Okay, the first thing we want to do is create a property for that class factory, and we will just call this .node.js framework factory equals new Node.js framework factory. There we go. Now instead of using the hard-coded value, we are now using the the class factory. Let me see, why is it complaining? Let me check. This is the class declaration. This is the constructor. This is normalize and the bootstrap. Oh, we don't need this because this is the remnant from the switch case. So I need to delete that. Okay. Now let's put a breakpoint here and we'll rerun instead of using the switch case statement. Now we're going to leverage the class factory. Okay. Okay, the REST framework value is Restify because that's the last value that we used. So it's going to go into this Restify application array, which means that when we go to the browser and we hit the endpoint, it should hit the Restify's. Okay, let me see, there's some problem. Okay, it gives an error on node server.bootstrap line number 20. Oh, this seems to be I'm looking at the JS file. There seems to be some problem here. Let me just stop and then let's do the rebuild. I'm just going to say terminate running task, and then one more time let me do a control shift B. Let us see if there's any compiler errors besides that one property output, which is not a problem, like I said, because it's a discrepancy in the TypeScript definition. Other than that, I don't see any problem here. Let me put a breakpoint in the server.bootstrap. Okay, so let us hit go, and let's hit F5 to see if we go into this bootstrap. Oh, it is still undefined, so there seems to be a problem with that construction of the string. So let me go back into the create Node.js framework and let us see if this value is properly constructed. So let me put a breakpoint here as well, and then we will just say go one more time, and let's start it again. Could be a simple string manipulation problem. Okay, let's check the value of REST framework. It's Restify. Okay, so let me run this in the watch window and see if that returns any value. Okay, the start case has oh, I see. The start case is trying to treat that as a Pascal case, which is a init caps. So which means that no wonder there is no uppercase Restify application in my declaration. So that's why it's not working. So we can fix this easily. What I would like to do is just change everything to this to suit the method, and then we'll just rerun this. You can use any case you want. I mean, like I just used the Pascal case. Okay, so now it's listening. Let's hit F5. Now it should hit the Restify application. Yep, as we can see that we are inside the Restify application, and then it's going to call the in-memory services get all function and return the JSON. Great. So we can go back to the launch.json, and we can fall back onto Express by deleting this, because if you don't specify any REST framework, it's going to fall back onto Express. Let's see if that does that. Since we already have a breakpoint in the Express application's get method, it should hit the get method of Express application. Let's go back and hit refresh. There we go. It hit the Express application this time. Before I conclude this section, I'd like to show how the error routes are working in all three frameworks. But before I show the error routes in Express application, I made a small mistake here. I did write a small function that that says it is catching the 404 error, but in reality this is only when there is a real error, because 404 error is something that happens when the URL is invalid and then none of these middleware methods will catch that. So the way to handle that in Express is to always provide an Express application.use function that takes the request response and next, and what happens is if none of the routes match, it'll always fall back to that. But when you override, when you use the function with an error argument, it'll only happen when there is a real error. Like for example, HTTP 500, when there is an internal application error or server error, only then this will be hit. So there's no way this breakpoint will be hit when you give a wrong URL. So I'm going to change the code a little bit to introduce the 404 handler, as well as this change this one to HTTP 500 error handler. So now if you look at it, I've introduced this function that takes 3 arguments without any error parameter, which will be the last one to be invoked because all others have a valid URL. So if it's a slash context, it'll always go there. If you give something like API slash some string, which is there is no match for that, so it'll always fall back into this 404 or unhandled middleware function. So it'll come in here. So let us do that. Now that we've done it, let me launch by hitting the run, continue or F5, whatever. Now it's going to wait for the request. And then we can either do it from the browser or we can do it from Postman. First, I'll show it from the browser. Okay, so let me hit F12 to bring the debug tools. And I want to look at the network. So let me close the console and show the network tab here. So let me hit, if you hit refresh, it's going to work because it's a valid URL. But now I'm going to enter something like this and hit enter. Now it's going to hit the error handler. As you can see, it falls into this unhandled error handler, and then it's going to return a status code of 404 with the message of not found. So let me give F5 here, and then if you go back, as you can see, it's a 404 not found, and you can click on that to drill into that response. So it passes the header as 404 not found, and in the response body it passes a simple string with not found, which is what we're doing from here. We pass the status code as 404 and the body as not found. Okay, that demonstrates the error route of Express application. Similarly, we'll put a breakpoint on the Hapi as well as on Restify to see how they are handling the 404. So let's go into Hapi. We'll put a breakpoint here. Here it's going to check if the status code equals 404. It's going to display the message, and also it uses the boom library to send the 404 back with whatever error message you pass on. So let me go back into the browser. Before we do that, we need to go to the launch.json and change it to happy. Yep. Let us restart the application. So it'll pick up the new launch environment variable. This time it's going to use the happy to handle the 404. Okay, so let's hit refresh again, and it hit the breakpoint. Let's hit go, and it displays a nice JSON object. Status code 404, error not found, and the message that we pass is check your URL. You can also see the same thing from here in the response, and also in the header you'll see that the status code is 404 not found. Okay, now we will switch it to Restify and see how that handles the 404 route. And we'll put a breakpoint on the error handler, 404 error handler in Restify application as well, right there. So let's restart the app. So it picks up the environment variable. Okay, hit F5, and let's go back and hit refresh. So it hits the breakpoint in Restify, and here we have invalid URL and not found as a message. So let's go there. Yep, and it says message not found, which is a serialized JSON object as well. And you can see that that's the status code and the response is not found. Okay, so that concludes section 1. In this section, what we did was We created an application abstraction on all three frameworks: Express, Hapi, and Restify. And we also created a class factory. So based on the environment variable that we pass in launch.json, it will invoke the appropriate framework. And we also added error routes and the API routes. Until we meet in the next section, happy coding.